Flight of the Space Shuttle Challenger on Mission 51L, the 25th flight of the Space Shuttle program, began at 11:38 a.m. Eastern Standard Time on January 28, 1986. It ended 73 seconds later in a structural breakup of the external tank and orbiter, in which the 7 crew members perished. The solid rocket boosters continued in flight and were destroyed by the range safety officer 110 seconds after launch. The delivery and assembly of 51L launch vehicle components began months prior to launch. The solid rocket booster segments were transported by rail to the Kennedy Space Center. The SRBs were inspected and partially assembled at the rotation, processing, and storage facility. The segments were then moved to the Vehicle Assembly Building, or VAB, where they were stacked on the mobile launch platform. The external tank arrived at KSC by barge and was moved into the VAB, where it was checked out and mated to the stacked solid rocket boosters. After orbiter checkout, Challenger was rolled into the VAB and mated with the assembled external tank and SRBs. The STS-51L vehicle was transported from the VAB to the launch pad on December 22, 1985. At a crawler speed of approximately 1 mile per hour, the journey takes about 6 hours. The launch was rescheduled several times, resulting in the final countdown on January 28, 1986. The weather was forecast to be clear and cold, with temperatures dropping into the low 20s overnight. The fueling of the external tank began at 1:25 a.m. Ice had accumulated on the launch pad during the night. Several water systems were opened slightly and allowed to flow into drains. The drains froze and caused overflows. High wind gusts spread the water over large areas and ice formed. The air temperature at launch was 36 degrees Fahrenheit. This was 15 degrees colder than any previous launch. At T-minus 7 minutes and 30 seconds, the ground launch sequencer began retracting the crew access arm. The arm can be put back in place within 15 to 20 seconds if an emergency arises and the crew must evacuate the pad. At T-minus 3 minutes and 15 seconds, gimbal checks of the orbiter main engines were performed. All 3 engines move in a pre-programmed pattern to verify ascent flight control. The gimbal sequence ends with the engines in their start positions. At T-minus 2 minutes and 55 seconds, external tank liquid oxygen pressurization began and main engine purging was completed. At T-minus 2 minutes and 50 seconds, retraction of the gaseous oxygen vent hood began. The ground launch sequencer verified its full retraction at T-minus 37 seconds. Sound suppression water was started at T-minus 16 seconds. At T-minus 8 seconds, hydrogen igniters were turned on to burn off any free hydrogen. 6.6 seconds before launch, Challenger's liquid-fueled main engines were ignited in sequence and run up to full thrust. Thrust from the main engines bends the shuttle stack. When it returned to vertical, the solid rocket boosters ignited. At T0, the hold-down bolts were explosively released. After the initial pre-release twang motion, structural forces on the assembly are dissipated through vibration at a rate of 3 cycles per second during the first few seconds of flight.
Space shuttle mission, and it has cleared the tower.
Roll maneuver was initiated at 7.724 seconds. The maneuver was completed at 21.124 seconds.
Normal throttles for most of the flight, 104%. We'll throttle down to 65%.
The main engines were throttled back to 65% at 35.379 seconds for about 16 seconds in order to alleviate loads during maximum dynamic pressure.
Velocity 2,257 feet per second. Altitude 4.3 nautical miles. Downrange distance 3.
The engines were then throttled up to 104% at 51.919 seconds.
Up 3 engines now at 104%.
Challenger, go at throttle up.
During the flight, telemetry data gave no indication of problems.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
The solid rocket boosters continued in flight and were destroyed by the range safety officer 110 seconds after launch. Data from nearly 200 cameras were analyzed during the investigation. The following sequence of events is based on the evaluation of film, video, and telemetry data. This graphic indicates viewing angles for 3 cameras in the vicinity of the launch site. The first view shown is from camera E63 at the lower right of the chart. At 0.678 seconds into the flight, a strong puff of gray smoke can be seen spurting from the vicinity of the aft field joint on the right solid rocket booster. The vaporized material streaming from the joint indicates there was not complete sealing action within the joint. This second view is from camera E60. The smoke can be seen between the right SRB and the external tank, and initially moves in the upward direction. The angle between this view and E63 is approximately 100 degrees. With E60 and E63 side by side, it is clear that when smoke is first visible to camera E60, it is not yet visible to E63. 0.2 seconds later, it becomes visible to E63 and is seen in multiple lobes, or puffs, reaching maximum visibility at about 1.9 seconds. A third, higher resolution camera, D67, was located east of the launch pad. D67 recorded this view of the smoke at approximately the same time of maximum development. Smoke appears to the right side of the SRB only, while normal water condensation vapors appear to the left. This plan shows that none of the cameras directly view the surface of the right SRB in the shaded region of the graphic. Analysis of film from several pad cameras indicated that the smoke came from between 270 and 310 degrees on the circumference of the aft field joint. As indicated on these pre-flight photos, the smoke emerged from just above the strut, between the SRB and ET, at a point along the longitudinal axis near the aft field joint. The multiple smoke puffs occurred at a rate of about 4 times per second, approximating the frequency of the structural load dynamics and resultant joint flexing. This greatly exaggerated computer animation depicts the flexing of the SRB joint. This flexing increased the gap between the tang and clevis at the location of 2 rubber O-ring seals. Last evidence of smoke above the aft attach ring appears at 2.733 seconds. The last indication of smoke dispersing below the aft dome appears at 3.375 seconds. Film records of the assembly of the solid rocket booster were reviewed to determine any evidence of cause for the smoke. Photographs taken just prior to mating of the booster segments at the aft field joint show the O-rings installed in the grease clevis grooves. A subtle variation was detected, but through computer enhancement was determined to be a shadow caused by irregularities in the grease. No evidence of O-ring defects was observed in any of the stacking photography. The facility gaseous hydrogen vent arm was not captured after retraction at launch. Film analysis, however, showed that it did not rebound and contact the vehicle or contribute to the accident. Post-launch inspection of the hold-down posts revealed that the kickspring assemblies on 4 of the posts were missing. Detailed analysis determined that the assemblies could not have become detached prior to T plus 850 milliseconds and were not a contributing factor to the smoke observed at liftoff. The next significant event was the development of the SRB burn-through plume. Camera E207, located about 6 miles north of the launch pad, shows the growth of this plume. The first evidence of flame appeared on the right solid rocket booster at 58.788 seconds. This occurred as the main engines had been throttled up to 104% thrust and the SRBs were increasing thrust. Camera E203 was located west of the launch site and gives an aft view. The exposure was set for the booster nozzle plumes. This graphic illustrates the location of the flare. The flare was located near the aft field joint, approximately 300 degrees circumferentially, which is consistent with the location of the smoke emissions at liftoff. Within half a second, the flame had grown into a continuous and well-defined plume. At about the same time, telemetry showed a